Okay, this is a short lesson on using some rational powers or powers that are fractions. So if I have something to the exponent 1/2, that is the exact same way as me writing the square root of whatever that base might be. If I have something to the exponent 1/3, that is the same way as me writing to the cubed root of whatever the base might be. The general rule is if I have some sort of base to the exponent of 1 over the fraction, that means I'm going to go to the nth root of whatever that base might be. So if I have, for example, let's say 9 to the exponent 1/2. Well, 1/2 is the square root, so this is going to be the square root of 9, which is simply 3. If I have 32 to the exponent of 1/5, that means it's the 5th root of 32 that I'm trying to find. Now, 32, the 5th root of 32, is 2 times 2 times 2 times 2 times 2 is 32. So the 5th root of 32 is simply just 2. So that's the rule if you have 1 over. Sometimes you have, it's not 1 over, it's a more complicated fraction. So at m to the n. So for example, let's say, using numbers, let's say I have 9 to the 3 over 2. If that's the case, my numerator and denominator. My denominator is the root I'm going to. The denominator is the root I'm going to. And then I'm going to take that answer and put it to the exponent of m, my numerator. It can also be written as the nth root, the denominator's root, and put the m in the inside of the square root. They're the exact same thing. So using numbers, if I have 9 to the 3 over 2, denominator is 2. That means the square root of 9. Then take that answer and cube it. The square root of 9 is 3, so I'm going to have 3 cubed, which is 27. If I have something like, let's say I have 27 to the 4/3, that would be the cubed root of 27 to the exponent of 4. Denominator is the root I'm going to go to. The cubed root of 27 is 3, so I'm going to have 3 to the exponent of 4, which is 81. 3 times 3 times 3 times 3 is 81. Okay, writing some things as a power of 5. So let's say, work backwards, I give you the square root of 5. I want to write it as a power. The square root of 5 is equal to 5 to the exponent of 1/2. If I give you the 4th root of 5, if I want to write it as a power, that's going to equal 5 to the exponent 1/4. The root is the denominator. Sometimes you might have it where the base is in the bottom of a fraction itself. 1 over 5, the square root of 5. That's going to be 1 over 5 to the 1/2, which could be written as a negative exponent of 5 to the negative 1/2. Maybe you might have a little more complicated, the cubed root of 5 squared. I want to write this as a power, okay, where it's written as an exponent. This would be 5, numerator, denominator, 2/3, 5 to the power 2/3. Maybe you have a case where it's, again, a little bit more complicated, 1 over the 4th root of 125. My objective is to write it as a power of 5. 125 is not the power of 5, so let's turn it to that. I have 1 over the 4th root. 125 is 5 cubed. Now I can write this as a power of 5 because that's 1 over 5 to the 3/4. Which could, because that's on the denominator of a fraction, could be written as 5 to the negative 3/4. Now I have it as a power of 5. These rules could also be written to go backwards. If I give you, for example, the square root of 27, and I want to write this as a power where a is a prime number, so as a base is a prime number, I have to change that into a prime number. 27 is not a prime number. I can change 27 into being 3 cubed, so I'm going to have the square root of 3 cubed. which then I can write it as being 3. Square root means denominator is 2, so 3 to the power of 3 over 2. Okay? If I have something that's like 1 over the cubed root of cubed root of 32. 32 is not a prime number, but I can make it as a base 2. So it's 1 over the cubed root. 32 is 2 to the power of 5. 2 times 2 times 2 times 2, 5 times. And now I can write it as a power. 1 over 2 to the exponent of 5 over 3. Numerator, denominator. And if it's on the bottom, I can also write it as a negative exponent, negative 5 over 3. Write it in rational form. So rational form is the square root form. So if I give you something like 8 to the 5/3, let's put it in rational form. This means the cubed root, denominator, is a root of 8 to the exponent of 5. Now the cubed root of 8, we can figure that out. That is just 2 to the exponent of 5. 2 to the exponent of 5 is 32. So I start off in rational form when I had a square root, and then I said, oh, I can actually figure that out because the cubed root of 8 is possible to figure out. Sometimes they will work, sometimes they won't. If I give you something like 7 to the 3/4, I can just express that only as a radical because I won't be able to figure it out. So that'll be the 4th root of 7 cubed. And there's no way to simplify that any further without a calculator. Okay, so this is just a short lesson on using some rational powers. If you have a to the exponent of 1 over n is the root you want to go to. If it's a to the exponent m over n, the denominator is the root, and the m is the power you take that answer to afterwards. Thank you very much.